everybody in here. So let's go ahead and take a look at this. What's the first thing we have to do? Okay, yeah, there's nothing to do inside either parentheses. So the first one is multiplied by the 7x. So what's our first step? 7x times 3x is 21x squared. Good. What's next? 7x times the positive 4 is positive 28x. I have to make sure we multiply every piece in the parentheses by the 7x. On to the next set of parentheses. What do we do there? Do the 5x times the 2x, which is 10x squared. Now make sure you put a plus in front of it because it's a positive 10x squared. And then 5x times negative 7 is a negative 35x. Are we done? No. What can we combine? 21x squared and 10x squared make 31x squared. And 28x and negative 35x make negative 7x. How many of you had that? Good deal. Okay, so for our next hour, we're shifting gears slightly, and we're focusing on the use of the variable in a little bit different way. In this case, the variable is just standing there for any generic number or for a place value. What we're going to look at now is a case where the variable actually has a value, we just don't know what it is yet. We have to figure it out. Looks like this. X equals 7. Most of you know that's what we call an equation because of the equal sign. So to figure out how to work with these, we first must define what that symbol means. Easier said than done. I mean, most people say, oh, I know what that means. But it's really tough to define it without using the word equals. But what it means is that whatever's on one side has exactly the same value as what's on the other side. So x has the same value as 7. In fact, you can think of it like it's a balanced scale. Whatever's on one side exactly balances what's on the other side. Now, all equations start out in this simplest of forms as a variable equals a number, and they're built up from there. Some things we can do to build onto our variables or use our basic operations. Add, subtract, multiply, divide. So let's add here. Let's say I'm going to add 5. So now on this side of the equation, it is x plus 5. I've built onto it, made it a little more complicated. But because of this idea of a balanced scale, if I add 5 to one side, this thing's going to tip unless I do what? Add to the other side. Whatever I do to one side, I have to do exactly the same thing to the other side in order to keep things balanced. So 7 plus 5 is 12. So I've made this equation more complex. I've built onto it by adding 5 to both sides. Now, most of the time, what we're going to do is not building equations, but solving equations. If you're given the command to solve, and you're given an equation like that, what it's asking you to do is to reverse this process. Take it back apart and get back to that point right there. Well, this equation was built by adding 5, so how are we going to take that apart? Subtract 5. We subtract 5, takes that 5 off. We have x there. But again, because of this balanced scale, whatever we do to one side, we have to make sure we do exactly the same thing to the other side. So we subtract 5 from the other side. 12 minus 5 is 7. So we're back to that form, x equals 7. Now, we built this equation, so we knew exactly how to take it apart. The difficult part is looking at an equation and figuring out how to take it apart. Or figuring out how it was built, actually. So let's look at something like this. 11 equals y minus 2. To figure out how an equation was built, we find the equal sign, and then we identify the side of the equation that has the variable. So that's this part over here. Now, on that side of the equation, we ask ourselves, what is keeping this variable from being alone or by itself. In this case, that's the 2. What operation was used to build that 2 onto this equation? We subtracted. So to take this apart, we're going to do the opposite, which is adding 2. So that's gone. We're left with y. We add 2 over here. 11 plus 2 is 13. Y equals 13. Now, if we get to this point and we're not sure if we did things correctly, we can always double check. The way we double check is we go back to the original equation and replace the variable with the value that we solved for. So instead of 11 equals y minus 2, it's going to be 11 equals 13 minus 2. 13 minus 2 is 11. So we do get the same exact value on both sides. If I have 7z equals 21, looking at this, what was done to build this equation? It's multiplied by 7. So to take it apart, we're going to divide by 7. Dividing by 7 makes that 7 go away. Leaves it with z. We divide this side by 7. 20 divided by 7 is 3. Z equals 3. Now those are some relatively simple equations, what's sometimes called one-step equations. So let's look at something a little more complex. (3x plus 2 equals 23). So here, we do the same thing. We find our equal sign. We identify where the variable is. So it's over there. This time there are 2 things that are keeping our variable from being by itself. We have the 3 and the 2. What operation is used to attach the 3? It's multiplied, and the 2 was added. Okay. Now if we ask ourselves how this was built, according to our order of operations, what's been done to x? Well, it's been multiplied by 3 and 2 has been added. Order of operations says which one happens first. Do we multiply first or do we add first? We multiply first. So when this equation was built, our variable was first multiplied by 3, and then the 2 was added. Now, when we go to take something apart, let's say you finish putting something together. Maybe it's a model or a piece of furniture, a toy for one of your kids or whatever. We've just finished putting it together. We put on the last piece. If we have to take it apart, what's going to be the first piece we take off? The last piece we put on. And then we're going to go in reverse order after that. So the exact same thing happens for solving an equation. It was put together by multiplying by 3 and then adding 2. To take it apart, we have to go in the reverse order. The last piece put on, adding 2, must be the first piece to come off. So we subtract 2. That piece comes off. That piece comes off. We're left with 3x. We have to subtract 2 from the other side. We get 21. Now we have to get rid of the 3 by dividing. So x equals 7. Again, if we're not sure of our work, we can take that back to the original equation and replace the variable with the value 7. So instead of 3x, it's 3 times 7 plus 2. We need to verify to see if that equals 23. Well, 3 times 7 is 21, plus 2 is 23. We get the same value on both sides of the equation. Okay, how about (42 equals 5y minus 3). What's the first thing we're going to have to do to try to solve this equation? Add 3. Very good. Takes off the subtracting 3. We're left with 5y here. Have to add 3 to the other side. 42 plus 3 is 45. Now, anybody have a question as to why we added 3? When this was put together, what was done to our variable, what was done to y, it first had to be multiplied by the 5, and then the 3 was subtracted. So to take it apart, we reverse that. So now we've taken off the 3. We added 3 to get rid of subtracting 3. We have to get rid of the 5 now by dividing by 5. 9 equals y. Once again, you can put that back in for y and verify that you get the same value on both sides of the equation. I'm going to leave that up to you to do. In your notes, solve that equation. That's the first thing I have to do. Add the 13. Making sure I do it to both sides. Again, notice I pointed this out at the end of the first hour. When I add or subtract, I can only add it to things with the same name. So I only add it to one piece on each side. So I'm left with the 2x here. This 11 plus 13 is 24. Now I have to divide by 2. When I divide or multiply, I have to do it to every piece. So the 2x divides by 2. The 2 cancels out, I get x. 24 divided by 2 is 12. So far, everything we've done with multiplication and division, there's only been one piece on each side, so it's been relatively simple. If you were to get into graphing and stuff like that, you'd have to divide with multiple pieces. And I'll show you that. We won't get into graphing, but I'll show you some cases where you have to do the multiple pieces in a little bit. How many of you got x equals 12 for that? Perfect. Okay. Looking at this one, we find our equal sign. We go to identify what side the variable's on, and what do we find? Yeah, the variable appears twice, but it is both on the same side of the equation. So if we think of this like our balanced scale, as Taylor said, we can just put our 5x and 3x together in one big pile. It's not going to change the way this balances. So 5x and 3x make 8x. We still have the plus 2 there. That equals 26. Now it's just like the equations we've been working with. What do we do next? Subtract 2. 8x equals 24, and then divide by 8. X equals 3. And now just like before, I can take x equals 3 and I can verify this by replacing x with 3. So 5x becomes 5 times 3 plus 2 plus 3x becomes 3 times 3 equals 26. So we need to verify that what's on the left side is going to equal 26. So 5 times 3 is 15. Second step, 3 times 3 is 9. 15 plus 2 is 17. Plus 9 is 26. So we get the same value on both sides of the equation. That's the next step. Looking at this one, oops, I forgot my X there. We see that the X appears twice, but it's once on each side of the equation. So we can't just push them together into a big pile anymore. We have to get rid of one of them. Well, which one do we get rid of? We're going to get rid of the smaller one. Between the 5x and the 3x, the smaller one is the 3x. How do we get rid of it? Yeah, mathematically we subtract. It's a positive 3x, so subtracting will make it go away. That leaves us with just 13 over here. Now we have to take 3x from the other side. The only piece we can take it away from is the 5x. So 5x minus 3x is 2x. We can't forget we still have the minus 7 there. Bringing that down. Now what do? Add 7. Perfect. So 2x equals 20. And then divide by 2. X equals 10. Once again, we could go back and verify, put 10 in for x. 5 times 10 minus 7, does that equal 3 times 10 plus 13? 5 times 10 is 50, minus 7 is 43. 3 times 10 is 30, plus 13 is 43. So we have the same value on each side of the equation. So we know that's a correct value. Now let's just see how well you guys have been paying attention. Give that one a shot in your notes. See if you can make that work. So we have things to combine on each side. So I'm going to look at each side separately. On the left side over here, what can I combine? 3x and 8x make 11x. We can't forget the negative 7. That's all we can combine on the left side. So now we're going to go over to the right. What can we combine over there? 6x and negative 3x make 3x. Again, remembering the plus 9. Now what? We have to get rid of one of the x's because there's one on each side. We'll subtract 3x. So we have 8x minus 7 equals 9. And then add 7. 8x equals 16, and then divide by 8. X equals 2. How many got x equals 2? Good. So, looking at something like this. Of course, what sticks out here is well, the parentheses, yep. That always, whenever we see parentheses, it should always scream at us, do something here first. In this case, is there anything to do inside those parentheses? No. Is there anything that needs to be done to the parentheses? Yes, multiplied by 3. So let's do that. 3 times 5x. 15x. 3 times negative 7. Negative 21. Good. Now it looks just like the equations we've been working on before. What do we do next? So add 21. So 15x equals 30. And then divide by 15. X equals 2. Once again, we could go back and plug that in and test to make sure we get the same value, but I'm not going to do that. I'm going to leave it up to you guys. You can do that if you need to. Looking at this one, tell me what to do. Five times the 7x is 35x, and then 5 times 1 is positive 5. And then subtract the 5. 105 equals 35x. And then divide by 35. 3 equals x. Your turn. So 2 times 5x plus 3 equals 46. Give that one a shot. So we have the parentheses. We're going to start by multiplying by 2. 2 times 5x, 10x. And 2 times positive 3, positive 6. Then what? Subtract the 6. So 10x equals 40. Divide by 10. X equals 4. Looking at one like this, it looks like those parentheses are almost unnecessary, but they are needed here. It doesn't look like there's anything multiplying the parentheses, but there really is. Just like when we have an inch, we sometimes don't say 1 inch, we just say an inch. Or x, we just say x instead of putting 1x in front of it. Same type of thing is going on here. This is really a negative 1 times the parentheses. We just don't put the 1 in there. So in order to solve this equation, we have to multiply that at parentheses by the negative 1. So the negative 1 times 5x is negative 5x. Negative 1 times negative 1, positive 1. Now I can't forget I have the 2x here. It still equals 16. So then 2x and negative 5x make negative 3x. So negative 3x plus 1 equals 16. What do I do next? Subtract 1. Negative 3x equals 16 minus 1 is 15. And then divide by negative 3. So x equals 15 divided by negative 3 is a negative 5. Questions? Well, if you guys try one. That was a little bit of a step up. Let's see how you're doing with it. So as we mentioned, we have things to combine on both sides. So I'm going to start on one side and complete that, then we'll do the other side. So on the left side, what do I have to do? Distribute the 7. So 7 times 2x, 14x. 7 times 5, positive 35. We have the negative 4x here. I can still combine 14x and negative 4x. Makes 10x. So 10x plus 35, and that is as far as I can go on the left side. So now I go over to the right side. What do I have to do there? Distribute the 5. So 5 times 6x is 30x. 5 times negative 3. Negative 15. I still have the positive 4. What can I combine there yet? Negative 15 and the 4. So the 30x doesn't change. Negative 15 and positive 4 makes negative 11. Good. Now I've reduced everything I can on each side. It's time to go ahead and start solving. I have variables on each side, which means I have to get rid of one. Which am I going to get rid of? Negative 10x. Subtract 10x, I should say. So 35 equals 20x minus 11. Then what? To add 11. So 46 equals 20x. And then divide by 20. So over here we have x. On this side we have a couple of options. 46 divided by 20 is 2.3 if it was a decimal. If we don't want it as a decimal, if we want to leave it as a fraction, 46 divided by 20, remember there's an equivalency between fractions and division. We can just turn our division into a fraction, then reduce 46 and 20. 20 goes into 46 2 times with 6 left over. And the 6 and 20 can both be divided by 2. Give me 2 and 3 tenths. So x is either 2.3 or 2 and 3 tenths. They're the same equivalent numbers, just in different forms. Any questions? What's that? That wasn't fair? Well, it's kind of a lead-in to the next portion. That might look something like this. Actually, I can't do that to you. I'll be nice. I'll make this 6 3/5 instead of 3/7. This looks ugly because we see the fractions and we kind of freeze up a little bit. But it's no different than any other equation. This is actually the same as having like 2x minus 7 equals 11. Here we would add the 7 and then divide by 2. Over here, what are we going to do? Add 5 and 1/4. So that's going to be gone. We're left with 3/8 x here. We just have to do 6 3/5 plus 5 and 1/4, which ends up being 11 and 17/20. If you're wondering how I did that, the steps that I skipped, follow my common denominator, which is going to be 20. 5 times 4 makes 20. 3 times 4 would make this 12. 4 times 5 makes 20. 1 times 5 would make that 5. 12 20ths plus 5 20ths. 12 plus 5 is 17 20ths. 6 plus 5 is 11. So I just skipped a couple steps there. So all we did was add. I see some lost looks out there. Everybody okay? Yeah, all I did is, that's exactly what I did here. I just didn't write it all out. So next, what do we have to do? We have to divide by the 3/8. Good. So x equals 11 and 17/20 divided by 3/8. Well, let's do that. Well, we have to change our 11 and 17/20 to an improper fraction. 11 times 20 is 220, plus 17 is 237 over 20. So dividing by 3/8, I'm going to multiply by 8 over 3. 20 and 8 can both be divided by 4, which will give me 2 and 5. 3 and 237 can both be divided by 3. Give me 1 and 79. So now 79 times 2 is 158. 5 times 1 is 5. 158 divided by 5. 5 goes into 15 3 times. Nothing left over. Bring down the 8. 5 goes into 8 1 time. With 3 left over, so it's 31 3/5. What do you think? Okay. We're not going to make you do a lot with the fractions, I promise. We can also run into actually, I want to do this as 2.1x. It'll work out better. 2.1x plus 3.3 equals 9.6. Now, again, it looks a little uglier, but it's just decimals instead of whole numbers. It'll be the same set of steps. So where would we start solving a question like this? Subtract 3.3. So all that's left over here is 2.1x. Over here, 9.6 minus 3.3 is 6.3. Then what? Divide by 2.1. X equals 3. Yeah.
I confused with how do you know whether not just multiply or say 20 for decimal?
That's a good question. When it's printed, it's a lot more obvious because it's down at the bottom instead of up in the middle. When I write it, my handwriting's a little sloppy. But it's all position. If it's down here, that's a decimal point. If it were up here, it would be multiply. Actually, let's do 3.5x minus 2.4 equals 2.1x plus 4.6. Try that one in your notes, see what you come up with, and then we'll go over it in a second. Now, a few of you still aren't finished, but let's go ahead and take a look. Where would we start here? Get rid of 2.1x. So that's gone. So this is 1.4x. You still have the minus 2.4 equals 4.6. Then what? Add 2.4. So this is gone. 1.4x equals 7. And then divide by 1.4. X equals 5. Yeah, I may have done something like this a few times before. You may see me doing some pretty complex calculations in my head, but calculations with numbers come down to patterns, and it takes a while, but I mean, I've been doing this for a few years. Once you start seeing the patterns, the calculations themselves are very easy. So you start to do a calculation, you see a pattern come up, and you just go with the pattern. Don't worry, it's not contagious. Let's do 3.8x plus 7.1 equals 4.5x plus 2.8. We'll do one for you that doesn't work out so nice. Tell me what to do. Subtract 3.8x. Good. So 7.1 equals 4.5x minus 3.8x is 0.7x. We still have the 2.8. And then subtract 2.8. So we've got 0.7x over here. 7.1 minus 2.8 is 4.3. And then divide by 0.7, which gives us 6.142857143 approximately. Sorry. Any questions? Like I said, it's all patterns. There's not a whole lot of calculation there. Well, generally in the problem, you'd specified what you have to, one of two things would happen. They either specify what you have to round to. Yeah, I was just kind of showing off a little bit there.
That's what I said.
Oh, sure. It'll be specified what you have to round to, or if we're dealing with dollars and cents, of course, you would round it to the nearest cent. So it'd be $6.14 if it was money. Yeah. Like I said, I've done this a few times before. I'm kind of good with numbers, otherwise this job would drive me nuts. Okay, our next step is now, rather than just doing generic equations, let's start applying it to something. So let's take a look at a business has total sales of $3,381. Each item sells for $23. How many were sold? Now, a lot of us will look at this and it's really simple to just divide it out. But what we're going to do here is we're going to practice using formulas. So we have a set formula where total sales is equal to the price per item times the number sold. Do we know the total sales? Yeah, that's the 3,381. Do we know the price per item? Yeah, that is the 23. Do we know the number sold? No, that's what we're looking for. So it's 23 times x. So we're solving for the number sold, or for x here. This is a relatively simple formula. What do we have to do? Divide by 23. 3,381 divided by 23 is 147. In my math lab, they will occasionally ask you to write out the equation or fill in the missing numbers in the equation.
Oh, so like not write about words or anything?
No, no. And on a test, as long as you have the right answer, I mean, I don't care if you guess and check. I mean, that's a valid method, is guessing and checking. Those simpler questions like that are often more difficult than the more difficult ones. For example, let's look at something like this. Frank sells 3 times as many cars as Stan. They sell a total of 128 cars. How many did each sell? There's two things we're looking for here. We're looking for Frank's sales and Stan's sales. We can't have two variables. So what we have to do is we have to figure out how to represent one of them in terms of the other. And we look at the problem and we can see that one of them does reference the other. And in this case, that'll be Frank sells 3 times as many cars as Stan. So if we let the number of cars sold for Stan equal X, Frank's number of cars sold would be 3X, 3 times that. So I'm going to pause there. Does everybody understand where X and 3X come from there? Frank was 3 times Stan, so we let Stan be X. Frank is 3 times X. Now we know that there's a total of 128 cars sold between them. So Frank's plus Stan's has to equal 128. Now again, you wouldn't have to write out that part of their names. But we do know that Frank is 3X, Stan is X. That adds up to 128. So now what do? Yeah, we combine the X's. Now it's not there, but this is another spot where we said that's really a 1X. So 3X and 1X make 4X. 4X equals 128. So we solve by dividing by 4. X equals 32. Now we're not done yet because we haven't answered the question. A lot of people solve the equation, they get that value for the variable, and they think they're done. But we still have to answer what the question was. The question was, how many did each sell? X represents 32. That represents how many Stan sold. Stan sold 32 cars. We still have to figure out Frank. Well, his was 3X, or 3 times Stan. So 3 times 32 is 96 cars. We can always double check. Do those add up to 128? Yes, they do. Similar to that, Pete sold 7 more cars than Harry. I'm going to abbreviate a little bit here. They sold a total of 57 cars.
7 times more cars?
7 more, period. How many each? How many did each sell? So again, we have Pete and we have Harry, and we're looking at the number they sold. Does one reference the other? Yeah, Pete sold 7 more. So for that Harry be X, Pete's going to be X plus 7. It's not times, it's plus, because it's just more, not times more. And we know that Pete's, which is X plus 7, plus Harry's, which is just X, has to add up to 57. Now what? X plus X makes 2X. So it's 2X plus 7 equals 57. And then subtract 7. 2X equals 50. And then divide by 2. X equals 25. Now what? I have to answer the question. Harry is X, so he sold 25. Pete is X plus 7, so 25 plus 7 makes 32. Now we've answered the question. Does anybody need a break? I'm going to just power through. I have about 15 or 20 minutes left. Anybody that really needs a break, we can take one if you want. No? Okay. Get it over with? All right, that's kind of what I figured. I was sensing the high energy level out there. I figured you guys just wanted to get it over with and get out of here. So another type of problem can look like this. let's say Pat sold 4 times as many cars. I'm going to say 4 times as many as Chris. Pat sold 51 more. How many each? How many did each sell again? So Pat sold 4 times as many items as Chris. Pat sold 51 items more than Chris. How many did each sell? So again, we have Pat and we have Chris. We're looking at the number sold for each. Now this one's similar to our first one. How are we going to set up our variables? Which one's going to be X? Chris. So the number that Chris sold is X. What's Pat going to be? 4X. Well, not 4X plus 51. Pat sold 4 times more. And also then that comes out to being 51 more cars. Okay. So what that means is we're not given the total like we were before, where they sold a total of this many cars together. What we're being told here is Pat sold 51 more than Chris. So we're not given the total, we're given the difference. So instead of adding, we have to subtract. So Pat, which is 4X, minus Chris, which is X, has to equal 51 cars, or 51 items. So now it's X minus, or 4X minus X, which is 3X, equals 51. And then divide by 3. X equals 17. So now we can go back and answer our question. Chris is X, that's 17 for Chris. Pat is 4X. 4 times 17 is 68. 68 for Pat. 4 times 17, yep. You could just add 51 to 17 would work too. Okay, so those are the simple problems where we're just dealing with quantities. When we start throwing dollars in there, it gets a little more complicated. The dollars or the revenue from an item is equal to the amount per item, the price, times the number sold. We looked at this a little bit before, but this is going to come into big play now in these problems. So let's look at an example where we're going to set up a small little stand, and we're going to sell t-shirts for, I'm going to keep it easy, $20 each, and hats for $10 each. We sell 3 times as many t-shirts as hats for a total of, let's see here. $1,800. How many of each did we sell? So setting this one up is going to become a little more complex. Looking at our t-shirts and our hats. Well, the first thing we define is just what we've been defining before, is the number sold. Just like before, one of them has to reference the other. Which one are we going to let be X? The number of t-shirts sold or the number of hats sold? The hats, because t-shirts are 3 times as many as the hats. So t-shirt's going to be 3X. But we're not given the total number sold, we're given the total dollar amount. So we have to convert this to dollar sales or revenue, which is that formula I just gave you here. The revenue is the price of each times the number sold. So what's the price for t-shirts? $20. How many are sold? 3X. So it's 20 times 3X. For hats, what's the price for hats? 10, and the number sold is X. So 10 times X is the dollars from hats. So I'm going to go ahead and multiply. 20 times 3X is 60X. So I have 60X in my dollars from t-shirts. 10X is my dollars from the hats. What do I know about those two? They add up to 1,800, right? 60X plus 10X adds up to 1,800. Now what? I screwed this up, by the way. That's okay, we'll keep going. Now we can combine 60X and 10X make 70X. And we divide to figure out what X is. This isn't going to divide out though, unfortunately. Yeah, it's 180, or 1,800 divided by 70 ends up being 25.71428571443 approximately. So it doesn't come out, but you get the point. It's 25 point blah, blah, blah. That's our X. I need to go back and find the other one. Let me try that again and see if I can get one that works out. So let's see here. Let's sell cups for $3. And we're going to sell banners for $5. We sell 4 times as many cups for a total of, let's see here, $85. How many of each are sold? Well, you guys kind of lead me through this one. I'll start us out with our cups and banners. Okay, the number of banners sold will be X. Cups will be 4X. Okay. Then what? Do our dollars sold? Okay. For cups, it's going to be what are we going to do with cups? 3 times 4X, which is 12X. Banners. 5 times X is just 5X. What do we know about those two amounts? They have to add up to 85. So 12X plus 5X has to add up to $85. Then what? Combine the 12X and 5X to get 17X, 85, and then divide by 17. X is 5. Are we done? No, we have to answer the question. X represents the number of banners. So there are 5 banners sold. How do we find the cups? 4 times the 5, which is 20 cups. So that's one type of these problems we can run into. The other type of this kind of problem that we can run into is this. So we sell cups for $3 and banners for $5 again. We sell a total of 25 items for $85. So once again, how many of each were sold? So we still have cups and banners. We're still representing the number sold. But we don't have one as being so many times the other anymore. We're not even told that one is this many more than the other. What are we told? 25 total items. So we know that the number of cups plus the number of banners adds up to 25. So whatever we put down here, that has to total 25. Well, the easiest way to express that, and this might be confusing for a second, just pick one of them to be X. Let's pick the number of banners sold to be X again. If I knew that number, let's say I told you that we sold 10 banners. How many cups did we have to sell? 15. How did you get that? Yeah, 25 minus 10. Well, we don't know that the number of banners sold is 10. The number of banners sold is X. So the number of cups sold is just 25 minus X. 25 minus however many banners we sold. So now to convert that into dollars, what's the dollar amount from cups? $3 each times 25 minus X is the number sold. What's our dollar amount for banners? $5 each times X is just 5X. Now we're going to have to do a little bit of work here with our cups. We have to do 3 times the 25 minus X. 3 times 25 is 75. 3 times the negative X, negative 3X. So now we have our dollar amounts, and we know those two have to add up to $85. So 75 minus 3X plus 5X equals 85. Now what? We combine the X's. Negative 3 and positive 5 make positive 2X. Then what? Subtract 75. So 2X equals 10. And then 5 by 2. X equals 5. So that tells us the number of banners sold, which is X, is 5. How do we find the number of cups? 25 minus 5, which is 20. If we put X for the cups, it would still work out. So the cups would be X and the banners would be 25 minus X. So now this is 3 times X, because it's the dollar amount for the cups, right? The banners would be 5 times 25 minus X. 5 times 25 is 125. 5 times negative x is negative 5x. So we have 3x plus 125 minus 5x adds up to 85. 3x and negative 5x make negative 2x plus 125 equals 85. And then subtract 125. So negative 2x equals negative 40. And then divide by negative 2. X equals 20. Now that looks like it's different than the first one, but remember, x now represents the number of cups. So that's 20. Banners is 25 minus 20, or 5. So it's the same answer. Just the variable is representing something different. So the equation looks a little different. Any questions? I'm going to have you guys try a couple here, and then we'll call her a night. Let's say we're going to sell t-shirts for $8 each. Sweatshirts for $12 each. We sell 4 times as many t-shirts as sweatshirts. For a total of, let's see here. $1,100. Figure out how many of each we sold. I see a block of you finishing up, so let's just take a look at this quick. So we have to represent the number sold first. Which one are we going to let be x? Sweatshirts. Okay, t-shirts will be 4x. 4 times as many t-shirts as sweatshirts. What do we put in for our dollar amounts? T-shirts are $8 each times 4x, so 8 times 4x, or 32x. Sweatshirts, $12 each times x, so just 12x. Then what? Equals $1,100. Perfect. And then 32 and 12 make 44x. And then divided by 44 gives us x equals 25. What's that tell us? 25 sweatshirts. And 4 times 25, or 100 t-shirts. What's that? Nope, because this was after we added the dollar amount. The 32. The 25 is just the number of items sold. It doesn't include the dollars. How many of you had that right? Okay. Let's take a look at a slightly different problem. T-shirts, again, $8. Sweatshirts, again, $12. We sold a total of 125 items. Actually, so the total of 250 items for $2,200. Again, how many of each were sold? See if we make that one work out. I realize some of you are still working, but let's take a peek. Which one's going to be X? Sweatshirts? Okay. What's t-shirts going to be then? 250 minus X. Now, it really doesn't matter which one we make X here. We saw that in the last one. But it's easier if we let the one that's the higher price be X, which is the t-shirts. That just keeps us from having to deal with negatives. Now, what do we do for the dollar amounts for the t-shirts? 8 times 250 minus X. Let's go ahead and multiply that now. So 8 times 250, 2,000, and then 8 times negative X minus 8X. So that's the dollars for the t-shirts. Dollars for the sweatshirts? Just 12 times X still. Now what? The t-shirts, 2,000 minus 8X. Plus the sweatshirts dollars is 12X. Has to add up to 2,200. Combine the X's, good. Negative 8 and positive 12 make positive 4. And then, subtract 2,000. 4X equals 200. Divide by 4. X equals 50. Now what? That's the number of sweatshirts, is 50. How do we find the t-shirts? 250 minus X, or 250 minus 50, is 200. How are we feeling? I'm seeing the full sign on across pretty much everybody's forehead right now, so I think we'll call that a night. The last half hour here, if you want to work in the computer lab next door, it'll be open. Yep, those of you in the other, just a second, and I'll scroll it back up. Let me finish this up. Those of you at the other locations, I think you have computers available either in the room or down the hall, except for maybe Ladysmith might be a little tougher to get to a computer right now. It should be open now. It opened, I believe, at 4 o'clock or 5 o'clock tonight. Quiz 1 needs to be finished by tomorrow night at 11:59 p.m. Homework 2 is due next week, next Thursday. So make sure you don't forget to do quiz 1. It is open now, and it will be open until 11:59. You can try the quizzes twice. So give yourself time. If you take the quiz and you don't like your score, you can redo it. The system automatically takes your highest score. So unless you get a perfect score on the first attempt, there's no reason not to try it again. So make sure you give yourself plenty of time for that. It'll give you the same questions with different numbers. It randomly changes the numbers. But you can go back and at least see your old questions and what you got wrong. Is that what you needed? Was that scrolled up there?
What?
Is that how far you needed it scrolled back up?
That last one that you were on.
Yeah. A little bit more?
No, the other one.
There?
Right there.
Okay. This one will disappear for just